Hello Junior Techies, and welcome to this video in which we will be taking a look at how to draw Lewis diagrams. Before watching this video, it is rather important that you take some time to watch the relevant theory videos and download and read through the relevant theory booklet, as I will often assume that you are familiar with the content that we will be applying in this video. For very simple molecules, we can draw Lewis diagrams by simply pairing up the unpaired electrons of the constituent atoms. We will be making use of this method to complete the first and second problem contained in this video. The octet rule, on the other hand, is a very useful guideline that we can use to draw Lewis diagrams. The octet rule simply says that atoms are happy, or at least some atoms are happy, having 8 valence electrons, as this allows them to be stable like the noble gases, the royalty of the periodic table. It is, however, very important to note that the octet rule is only a useful guideline and does have limitations. Some exceptions to the octet rule include the transition elements, hydrogen, beryllium, and boron. Hydrogen is happy with 2 valence electrons, beryllium is happy with 4, and boron is happy with 6. We will be applying the octet rule in the third and last problem contained in this video. The first problem says, draw a Lewis diagram for boron trifluoride. We start off by writing the element symbols. We then take a look at the periodic table in order to establish how many valence electrons each of these atoms contain. Since boron is in the third group of the periodic table, we know that it contains 3 valence electrons, which we can represent around its symbol as either dots or crosses. In this video, I will be making use of dots, as you can see on the screen. Fluorine, on the other hand, is in group 7 of the periodic table, and it therefore contains 7 valence electrons. So we draw 7 dots around each fluorine symbol. We now notice that boron has 1, 2, 3 unpaired valence electrons, while each fluorine atom only contains 1 unpaired valence electron. We can now go and pair up these unpaired valence electrons in order to draw the correct Lewis diagram for boron trifluoride as displayed on the right side of your screen. The next problem says, draw a Lewis diagram for H2O, also known as water. We again start off by writing the element symbols, and can then turn to the periodic table to establish how many valence electrons each of these atoms contains. Since hydrogen is in the first group on the periodic table, it contains 1 valence electron. Oxygen, on the other hand, is in group 6 and therefore has 6 valence electrons. We notice that oxygen has 2 unpaired valence electrons, while each hydrogen atom has 1 unpaired valence electron. We can now pair up these unpaired valence electrons in order to obtain the correct Lewis diagram for H2O as displayed on the right side of your screen. In this problem, we are going to be making use of the octet rule in order to draw the Lewis diagram for carbon dioxide. We start off by using the periodic table to determine the total number of valence electrons available to us. Carbon is in group 4 of the periodic table and oxygen is in group 6. So we can add up these valence electrons. But remember, carbon dioxide contains 2 oxygen atoms, and that is why we multiply 6 by 2. We get a total of 16 electrons. We now need to establish which one of the atoms will be the central atom. Remember, the central atom is the atom that will have the lowest electronegativity. From our periodic table, we establish that carbon has an electronegativity of 2,5, while oxygen has an electronegativity of 3,5. Since 2,5 is lower than 3,5, we know that carbon will be the central atom. So we write down its symbol and place one oxygen atom on either side. We will now draw a pair of electrons between carbon and each of the oxygen atoms to create one bond. This means that we have used up 4 electrons and are left with 12. Now we can complete the octets of our terminal atoms, which are oxygen. To do so, we add 6 electrons to each one of the oxygen atoms. In doing so, we have used up the 12 electrons and are left with none. We now notice that carbon only has 4 electrons surrounding it, while oxygen has its octet complete. We need to ensure that all of these atoms have their octet complete. So to do so, we can go ahead and move some of the electrons on the terminal atoms to the center so that the central atom also has its octet complete. We start off with the oxygen on the left and move a pair of electrons to the center. Carbon now has 6 valence electrons. That is still not enough, so we go to the oxygen on the right and we move a pair of electrons to the center. Having done so, we have completed, or have at least correctly drawn, the Lewis diagram for carbon dioxide. And we know that our diagram is complete because all of the atoms have their octet fulfilled. Or in other words, each of the atoms have 8 electrons surrounding it. Notice that between carbon and each oxygen atom, there are 2 pairs of electrons. This simply means that carbon is creating a double bond or forms a double bond with oxygen. Welcome to the very last question problem in this video. Here we will again be applying the octet rule, but in this case to draw a Lewis diagram for hydrogen cyanide, also known as HCN. So we again start off by determining the total number of valence electrons available to us. From the periodic table, we can establish that hydrogen has 1 valence electron, carbon has 4, and nitrogen 5, giving us a total of 10 valence electrons. We now need to determine which one of the atoms has the lowest electronegativity and will be the central atom. At this point, junior Takis, it is very important for you to take note of the fact that hydrogen, regardless of its electronegativity, will always be a terminal atom. This leaves us with carbon and nitrogen. We find that carbon has an electronegativity of 2,5, while nitrogen has an electronegativity of 3. Since 2,5 is smaller than 3, we know that carbon will be the central atom of this molecule. We write down the symbol for carbon and then place the hydrogen and nitrogen atom on either side. We use a pair or at least 4 electrons to create one bond between carbon and hydrogen and one bond between carbon and nitrogen. This means we have used up 4 electrons and are left with 6 electrons. We now need to ensure that our terminal atoms have their octet complete. But remember that hydrogen is a very special atom. It is happy having only 2 valence electrons. So we can use the 6 electrons to complete nitrogen's octet. Having done so, we use up the 6 electrons and are left with none. But now we notice that although nitrogen has 8 valence electrons, carbon only has 4, so its octet is not fulfilled. Remember, hydrogen is happy with its 2 valence electrons. What we can now do is move electrons from nitrogen to the center in order to complete carbon's octet. So we start off with 1 pair and move it to the center. Carbon now has 6 valence electrons surrounding it, But that is not enough, it needs 8. So we take another pair of electrons and move it to the center. We now have drawn the Lewis diagram correctly for hydrogen cyanide, as you can see, because each of the atoms has its octet fulfilled, except hydrogen, of course, which is happy with 2 valence electrons. Thank you very much for taking your time to watch this video. Remember that in order to reinforce all of the concepts that you have learned in this video, you need to go and practice as much as possible. Well done, Junior Tukkies. I hope to see you again in the video that follows this one.